Mensuration is really the art of turning shapes into logic. Once you stop seeing it as a formula chapter and start seeing it as a pattern chapter, the whole topic becomes far easier. This opening frame sets the tone perfectly. First, build the foundational understanding, then move into the faster tricks and shortcuts that help in CAT level questions. Keep that mindset because every good mensuration problem is asking you to visualize, compare, and simplify before you calculate. The core idea here is very simple. A 2D shape becomes a 3D solid when you add height or extrude it. That is why the base area matters so much, because the 3D volume is built on top of it. Think of a circle becoming a cylinder or a polygon becoming a prism. The cleaner your understanding of the flat base, the easier it becomes to handle the solid above it. The why of mensuration is what makes the chapter powerful. Proportionality tells you how dimensions control scale and volume. Spatial vision helps you unfold or build objects mentally. And pattern recognition lets you spot hidden structure quickly. In exam settings, that is a huge advantage because the fastest solver is usually the one who sees the shape relationship first, not the one who starts punching numbers immediately. The golden formula brings the whole idea together. Volume equals base area multiplied by height multiplied by a shape constant. For prisms, that constant is 1. And for pyramids, it is 1/3. That is one of the cleanest facts in mensuration, and it is worth remembering exactly because it appears in many forms. The deeper lesson is that 1D length grows into 2D area and then into 3D volume through height. This challenge problem is built like a typical CAT-style application question. A tank with radius 100 feet fills to a height of 7 feet, and the goal is to find the filling rate using the given time. The important step is not to rush into arithmetic, but to identify the principal base, the volume, and the time correctly first. Once those pieces are in place, the rest is just controlled computation. The standard solution takes the direct route. Calculate the base area, multiply by height to get volume, and then divide by time to get the rate. That gives a perfectly valid answer. But it is also exactly the kind of path that costs precious seconds in a timed exam. This slide is a good reminder that correctness matters, but speed matters just as much when everyone else is under the same time pressure. The topper's approach is where the real exam skill shows up. Instead of expanding everything fully, you cancel variables early and keep the expression compact. In this case, using the volume formula with the circular base lets you simplify the calculation mentally and reach the answer in a few steps. That is the kind of thinking that turns a long numerical into a short mental math routine, which is exactly what high-level competitive exams reward. This slide pushes the key scaling insight. When radius scales by a factor, volume scales by the cube of that factor. That is why a radius ratio of 4:7 gives a volume ratio of 64 to 343, not 4:7 or 16:49. A lot of students lose time because they instinctively compare raw sizes instead of comparing the correct power relationship. Once you train your mind to think cubically, these questions become much more predictable. The speed hack is all about replacing brute force with proportional thinking. Rather than calculating two separate absolute volumes, use the ratio formula directly and let the geometry do the work. That is especially useful when the question gives you two similar solids with different radii and heights. The takeaway is straightforward. In mensuration, raw data is slower than structure. So always look for the structural shortcut first. The advanced formula brings in triangle geometry through the end radius and semi-perimeter. The triangle area written as R times S becomes a useful tool whenever a figure is inscribed or when the problem hides a triangle inside a larger shape. This is the kind of formula that separates routine solving from sharper geometric insight. For inscribed 3D geometry questions, that little connection can save a surprising amount of time. This cheat sheet is the kind of revision page you want to come back to again and again. The formulas are compact, the observations are powerful, and the big exam habits are clearly stated. Volume scales cubically, area scales quadratically, and pi should stay symbolic until the final step. That final reminder is especially useful because premature approximation often creates avoidable errors. If you remember the patterns, not just the formulas, mensuration becomes a lot more manageable under pressure.